Students, in the last class we discussed about the structural isomers of the coordination compounds. In today's class we will discuss about the stereo isomers of the coordination compounds. Okay, so that is stereo isomers or isomerism. Okay, so here in this stereo isomerism, two types is there, as I told you: geometrical and optical. Okay, students. So geometrical isomers means the compounds having the same molecular formula, same structural formula, but differ in the arrangement of atoms in the three-dimensional space. Okay, so that is called as geometrical isomer. In that geometrical isomer, two types is there: cis and trans. What is cis? What is trans? I'll explain with example. I'll write example here, students. Okay, and consider example. Okay, that is A2 is with the coordination number. So if you write this, students, if M is the central metal atom, then A, B is there. So this A, B represents what? Cis isomer. Okay, next, if you take again two bonds are there, here A, B is there, then that represents trans isomer. Remember this one is cis, this one is trans. Okay, so by taking this one, students, I will explain what is geometrical isomer, what is cis and trans isomer. So listen, here the molecular formula of both the compound is Na2B2 only. Correct? The molecular formula of the compound remains same. Okay. Next, the structural formula is this is also square bracket, this is also square bracket. The structural formula is also same. Molecular formula is also same, as well as structural formula is also same. But only the difference is what? Arrangement of atoms in the three-dimensional space. Okay. Here the arrangement of atoms are adjacent to each other. Here the arrangement of atoms are opposite to each other. Here the same ligands, identical ligands are on the same side. Then they are called as cis isomers. If the identical ligands are on the opposite side, then they are called as trans isomers. So this is the example. I'll write the definition. What is geometrical isomer? Or isomerism you take. The compounds having same molecular formula, same structural formula, but differ in arrangement of atoms in three-dimensional structure, called as geometrical isomers, and the phenomenon is called as geometrical isomerism. Continue with the structures are called as geometrical isomers, and the phenomenon is called as geometrical isomerism. You add this word here. Okay. So in the types are there. One is cis, another one is trans. So what is cis isomer? Okay, two identical ligands are adjacent to each other. Two identical atoms are adjacent to each other, then they are called as cis isomers. What is trans? Okay, two identical ligands are opposite to each other. That is called as trans isomers. So what are the cis positions here, students? Consider this is 1, 2, 3, 4. Position 1, 2, 3, 4. Here cis position is 1, 2, 2, 3, 3, 4, and 1, 2. Cis position 1, 2, 2, 3, 3, 4, and 1, 4 is the cis position. And trans position means opposite to 1, 3, and 2, 4. This is the trans position. So here, geometrical isomerism means the compounds having the same molecular formula, same structural formula, but differ in the arrangement of atoms in the three-dimensional space or three-dimensional structure called as geometrical isomers, and the phenomenon is called as geometrical isomerism. Okay, so in that two types is there, cis and trans. What is cis isomer? This is cis isomer. The two identical atoms. Okay, so any two. Now exactly I am telling any two. Okay, so the two identical atoms and ligands are adjacent to each other when they are said to be what? Cis isomers. Here, the two identical atoms are opposite to each other when they are said to be trans isomers. So this is in coordination number 4, that is square planar structure. Okay, this is in coordination number 4. So you consider the coordination number 6. Coordination number 6, that is octahedral structure. Here the formula of the compound is MA4L2. MA4L2. So here consider all are unidentate ligands. All are unidentate ligand. Unidentate means 6 is there, means only one bond. They form only one bond. Here A form only one bond, so 4. L form 2 only one bond, so 2. 4 plus 2 means 6. That is coordination number 6. All are unidentate ligands. They have the capacity to form only one coordinate bond. Okay. So here if you write this M is there. This is the structure here. Here. Okay. So M. This is the structure. This is also M with this structure. Okay, so here A, this L and L. Okay, here A, and here is L, and here is. So if you consider this above structure and below structure, students, we are going to understand. Listen, these two ligands, identical ligands, are adjacent to each other. L and L are adjacent to each other. Hence, this is a cis isomer. Here, two are opposite to each other. Then this is trans isomer. Understand? This is cis isomer and this one is trans isomer. Okay. Next, I am considering this one as a unit-ended ligand. So, if I consider, rub this. If I consider a bi-dentate ligand, okay, that is the formula M L L twice A2. That is a bi-dentate ligand. Example is ethane 1,2-diamine. Correct? That is NH2. Here I write NH2, CH2, CH2, NH2. Assume this M is NH2, CH2, CH2, NH2 bi-dentate ligand. So listen, M is here, students. Okay, so 6 bond it can form. If it is a bi-dentate ligand means 2 into 2, that is 4 plus 2, 6. Coordination number 6 only. So formula is M L twice 8. That is bi-dentate ligand. Okay. So if this type of compounds are there, listen, this is NH2, CH2, CH2, NH2. Right? Next, similarly, NH2, CH2, CH2, NH2. Here A is there, A is there. So these two are adjacent to each other, correct? So this will form which type of structure? Cis. They are adjacent to each other, then they form cis structure. Here you consider M with the this form. This may be written as NH2, CH2, CH2, NH2. Here NH2, CH2, CH2, NH2. Here A, here A. If the two identical ligands are adjacent to each other, then they form a cis structure. If the two identical atoms are opposite to each other, then they form trans structure. So in the square planar structure, students, only one possibility is there, that is M A2B2 type molecule, they form cis and trans isomers. If octahedral form, two types of formulas are there. If they are unidentate, they form cis and trans. Even though they are bidentate, they form cis and trans isomers. Understand? So this is our the geometrical isomerism. I will give each and every example for one formula. Okay, let's just rub this. So students, here, first one, that is square planar with the formula Ma2B2. So example for this is Cu NH3 twice, Cl twice. Okay. So here, students, the central name of the ligand I will write. You know the nomenclature. That is diamine dichlorido copper 2. This is the name of the compound. So if we write the structural formula or geometrical isomers for that. Geometrical isomers. Okay, and right, this is a covalent structure means. Okay, so here it is NH3. Bonding is done through nitrogen atoms with NH3, NH3, Cl, Cl. Then if you want to write the name means cis followed by the name of the complex. Cis followed by the name of the complex. Cis diamine dichlorido copper 2. Understand? Next. If you want to write the structure for this, for a transform, then here it is NH3, here it is Cl, then here it is NH3, here it is Cl, then this is trans followed by name of the complex. This is trans diamine dichlorido copper 2. Understand? This is square planar structure. Understand? So another one example I'll give, that is for octahedral. Okay, so in this octahedral formula Ma4N2. Ma4N2. The formula of the complex is CO NH3 4 times Cl2. Okay, here plus charge is CO NH3 4 times Cl2 plus. So here students, octahedral structure means cobalt is the central metal atom. This is the octahedral structure. There 4 NH3 atoms are there. They written in this form. Here it is Cl, here it is Cl. If you write the power with the plus charge, because we have plus charge here. So whole complex is like this. Okay, instead of writing this, you simply write this much and write the plus charge. Understand? Next. So the two identical atoms are adjacent to each other. Then it is 6. How many atoms are there? 4 means tetraamine. How many chloride atoms are there? 2. Then dichlorido. I'll continue here. Okay. And cobalt 3 complex. Correct? Next, if you have to write the same compound, that is CO. Here is NH3, here NH3, here NH3, NH3, here is Cl, here is Cl. So I write the ligand here, which represents the system trans isomers in the different colors, and you will give it. So here, this one is Cl, this is Cl, Cl, Cl. This represents cis and trans isomer. Here I write, this is Cl, this is Cl. Represents cis isomer. Here is Cl, here is Cl. Represents trans isomer. Okay, and write in a different color, then you will easily understand. Then this is trans followed by name of the complex, that is trans tetraamine trichlorido cobalt 3 complex. Understand? So this one is trans tetraamine dichloride cobalt 3 complex. Understand, student? So this is one type. So another one is there. In this, the type of the formula A2 L2 if it is a bidentate ligand. So example for this is cobalt En twice Cl2 plus cobalt En twice Cl2 plus. So the name of the compound is going to write, that is ethane 1,2 diamine. So I will write it here. So bis ethane 1,2 diamine. Okay, dichloride cobalt 3 compounds. This is the name of the compound. Bis ethane 1,2 diamine dichloride cobalt 3 compounds. I taken bis here because the ligand itself already like is there. That's why I use bis as a prefix. Okay. If you write the diagram of this or the structure of this, students, so this is cobalt. Okay. Here 6 structures are there because it is octahedral. This is E. Correct? As I told, NH2, CH2, CH2, NH2. That I simply written as E. So this one is E. Here it is Cl, Cl. Then the name of the compound is right here. This one is Cl here. Correct? So the name and structure is cis followed by name of the complex. So that is cis bis ethane 1,2 diamine dichloride cobalt 3 and the name of the complex. Okay. Next, you want to write the structure. Again, cobalt is there. This is octahedral structure. Here it is E. Here it is E. Correct? They form a coordinate. All are coordinate quantities. Is the right students? Everything we wrote here is a coordinate quantity. Okay, so here it is, here atom is here and here. If the two atoms are identical atoms are opposite to each other, followed by name of the complex. What is the name of the complex here? Trans bis ethane 1,2 diamine dichloride cobalt 3. This is the types of geometrical isomers, cis and trans. Another one type is there for the formula Ma3P3. I'll explain now, students. So first you be thorough with this square planar complexes. If square planar complex is there, only one type of ligand can form, that is Ma2B2 type, then they form a cis and trans isomers. Okay? If octahedral is there, then Ma4L2 complex is there, then Ma2 Ln twice complex is there. If it is a unidentate and a bidentate ligand. So another one type is there, that is also a geometrical isomer, that is rub this and you get to know. That is also octahedral complex only. Okay, that is complex, octahedral complex of type A3P or Na3 L3 you will take. Okay, A3 is L3. So all the emphasis, for example, CO NH3 3 times Cl 3 times. Name is triamine chlorido cobalt 3 complex. Okay, students, if this type of complexes are there, then they are considered as facial and meridional isomers. Facial and meridional. Remember, so here I write this is a cobalt with 6 bonds. Okay, so what made them meridional and facial? And right here, this is cobalt with 6 bonds. Okay, how many complex ligands are here? NH3 3 times and Cl 3 times. Correct? So here, students, if you want to check CONH3 3 times is there, you just write NH3, NH3, NH3 here, and Cl, Cl, Cl here. Okay, so if we write the geometry here, okay, these form the C phase. Okay, so this type of isomers is called as facial isomers. Okay, so right here, this type of isomers is called as facial isomers represented by phase. Okay, so the name of the complex is, that is phase triamine trichlorido cobalt 3, because the arrangement of the ligands is in the facial isomerism form. Okay, so what is this meridional? So one is facial piece, another one is meridional, represented by 1. So here what happens? NH3 is here and here. One Cl comes here and NH3 is here. So Cl, they are in this form. Understand? So this type of, one of the ligand is in the opposite phase. So that type of isomers are called as meridional isomers. You just remember, students, if all the identical ligands are adjacent to each other, then that is facial. So NH3, 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 Cl, Cl, Cl. So one is defective, NH3, NH3, Cl, NH3. One is the transposition. So this type of arrangement is there. Then there is meridional isomers are they called as meridional isomers, and it is represented by Mer. And the name of the complex follows: Mer triamine trichlorido cobalt 3 complex. So this is the geometrical isomers exhibited by the octahedral complexes. If all are unidentified but the formula is Ma4L2, then they are shown cis and trans isomer. If all are unidentified but they have the formula Ma3B3, then they form facial and meridional isomers. If the is unidentified as well as bidentate ligand, and then they show cis and trans isomers. So this is all about the geometrical isomers exhibited by coordination compounds with the coordination number 6 octahedral complexes. In in square planar, I told only cis and trans isomer. Okay, so this is all about the geometrical isomers. Another one is there, that is optical isomers. Okay, we will discuss about the optical isomers. Next one is optical isomerism. So what is this optical isomerism? The compounds having same molecular formula, same structural formula, but they differ in the rotation of the plane polarized light. Okay, and right here first, compounds having same molecular formula, same structural formula. Okay, but differ in what? But differ in rotation of plane polarized light. But differ in the rotation of plane polarized light, called as optical isomers, and the phenomenon is called as optical isomerism. Okay, so in the type is there, one is dextro, another one is levo. So if the compounds rotate plane polarized light towards right. That is, right means like this. Okay, this is a compound, if this is a light, it will rotate the plane polarized light towards right side. Okay, so that means clockwise, called as towards right, that is clockwise direction, called as dextro-rotatory, denoted by D and plus. Denoted by D and plus. Next, levo means if the compounds rotate plane polarized light towards left, that is anti-clockwise direction, called as levo isomers. Understood? You have to continue with the students. Don't stop here only. Towards right, called as dextro isomers. Towards left, called as levo isomers, and represented by here are minus 1 and R. LR minus. Okay, so this is optical isomerism. Compounds having the same molecular formula, same structural formula, but differing the rotation of the plane polarized light, they are said to be optical isomers. There are two types, one is dextro, another one is levo. Dextro means if they rotate the plane polarized light in the clockwise direction, they are said to be dextro isomers. If they rotate the plane polarized light towards left, that is anti-clockwise direction like this, then they are said to be levo isomers. Okay, only the cis isomer shows the optical isomerism. What is the reason for that? I'll explain. Only the compounds in the coordination number 6 practical compounds shows this optical activity. In that, especially cis isomer shows optical activity. Why? Because to show the optical activity, we want enantiomers. Enantiomers means non-superimposable. Non-superimposable mirror images. So students here, listen, cis isomer you consider, that is A4, L2. Okay, so cis A4, L2, that is M is here, A4 means here, L means B. This is this position, correct? If you place mirror here, if you place mirror in front of this, then it will appear like. So this L here, this L here, A, and D. Correct? So listen students, if we take this isomer and we place this above this, first, this is structure 1, this structure 2. Okay, these two are mirror images. If you take this structure 2 and if you place above the structure 1, here the ligands, this will overlap with L, correct? These two in the same position, these two in the same position, this A also in the same position, but the only the change is the A is superimposed with L, this L is superimposed with E. So this is not a superimposable mirror image. So we want enantiomers, non-superimposable mirror images. Understand? So it is like exactly like this. So students, this is one and so this is a mirror image, correct? If you place, this is a mirror image. So if you place this and here, this finger, the middle finger is overlapping each other, but this thumb is overlapping with this finger. So this is example for what? Non-superimposable mirror image. There may be a chance of superimposed with 1 or 2 ligands. Here listen, middle finger is exactly overlapped with the middle finger only, but remaining 4 are different. Similarly here, all these ligands are superimposed with each other. Only these two positions are not superimposed with each other. That means they are enantiomers. So students, if this type of cis isomers forms the mirror images and they show optical activity. If it rotates the plane polarized towards right side, if it is dextro, then this must be levo. Okay, so one compound, if it rotates the plane polarized towards right side, the mirror image of that compound forms the rotates the plane polarized light towards left side. Okay, so another one example is that is L 3 times. Okay, for example, CO-N thrice. So it is a bidentate ligand, means 3 to the 6, coordination number is 6. So here if you take students, this is CO, octahedral complex, correct? Here it is here, here it is here, here it is here. So if you write the mirror image for this, you will get again the same. Here it is here, here it is here, here it is here. If you place this structure 1 and this is structure 2, if you place the structure 2 above the structure 1, this is not superimposable. So this type of compounds, that is AMALL3, also forms what? Dextron, and optical activity, that is dextron LIGO. Understand? So only the cis isomers shows optical activity, not trans isomers. What is the reason for not exhibiting the optical isomers by trans isomer is, here only you consider this trans isomer. So example for that is, yeah, here L, A, correct? So if you write the mirror image for the students, M place here, again the octahedral structure, correct? So this will become this is this one and this one. So the mirror image of a trans ligand is exactly same as the first structure. Understand? If the mirror image and this is a superimposable mirror image. If we take this structure 2 and place on the structure 1, each and every ligand is superimposed with each other. That means there is no chance of rotating the plane polarized light in the opposite direction. Both the ligands, both the structures are same, both the mirror images are same, then their optical activity is also same. Okay. If it rotates the plane polarizing light towards like this will also rotate the plane polarizing light towards right. So their optical activity, they possess symmetry. If they are symmetrical, their activity gets cancelled and become 0. Understand? Here if you cut this, they are not symmetrical. Or if cut like this, then also they are not symmetrical. So if asymmetric molecules and they are enantiomers if they form, and the cis isomers they are, then they are optical isomers. If they are trans, they possess symmetry, their optical activity gets cancelled, hence they do not show optical isomerism. So this is about the isomers exhibited by the coordination compound. So this completes the isomerism. In the next class, we will discuss about the valence bond theory of the certain, and that is very important for 3 marks. We will discuss in the next class. Okay.